Okay, look at this. I'm making a small change in this simple Hello World node server. I have made a new branch already, and I will now commit and push my changes to GitHub. Pushed, there you go. Let's now open a new pull request from that branch. Pull request created, and there is a new CI that has been triggered. A few moments later, look at this. I have a preview environment created for me where I can see my changes live. Hi there. This is a first tutorial from a new series called Advanced DevOps. In this series, I will work on real-world problems that are more challenging than the usual CI/CD pipeline and simple projects you can easily find online. So let's dive in. Let's start by picking our tech stack for this project. I'll be using GitHub to host the code base and GitHub Action to run the preview environment's pipeline. The app itself will be containerized using Docker and then pushed to a private registry. It will also be deployed to a single node Kubernetes cluster, which I'm going to be building from scratch using K3s in a Hetzner VPS. And the domain name will be managed using Cloudflare. I will be using Terraform as my tool of choice for infrastructure as code, with PyInfra to actually provision the Hetzner instance. If you're not familiar with PyInfra, it's an automation tool similar to Ansible. In order to build the actual Kubernetes manifests, I will be using JSONnet. It's a generic JSON templating language, and I really like its simple yet powerful syntax. Other options I could have picked here are Customize or Helm. And finally, to glue everything together and remember different commands and arguments, I will use task files, which are a modern alternative to make files, but with a much easier to learn YAML-based syntax. The way I like to work on big projects is by splitting them into smaller, more testable milestones. I find this way it becomes way easier to troubleshoot issues, especially if you have many moving parts in your system. The first step is to create a simple demo app, add a Docker file, build it and test it locally, and then push the container to our private registry. The next step is to deploy our single node Kubernetes cluster in Hetzner Cloud. After that, I will add a catch-all domain name in Cloudflare to be used to access our preview environments. In step 4, I will add the necessary secrets to allow GitHub Action to push the images and then deploy them to the cluster. In step 5, I will focus on preparing the necessary Kubernetes resources to deploy new preview environments. And finally, I will add some workflows in GitHub Action that, when triggered, will do the actual image building, pushing, and resource creation in our cluster. Let's start with the first step, building and containerizing a simple app. This is a very basic Node.js HTTP server that is going to be listening for HTTP requests on port 3000. It will return a simple text that says "Hello World" for any request it receives. Nothing fancy here. The Docker file is also very basic and simple. It just copies the app code as is, exposes port 3000, and runs the code with the node binary. I will be using the command task here very often. I prefer to do that because if I need to revisit this project after 6 months to make a small change, for example, I don't need to remember what command I need to use in order to run some specific actions. It's all there in the task file. I'm going to be logging into the private registry first. Then I'll build the container for my local platform and architecture. In this case, I'm using dev container in my ARM MacBook, so it needs to be Linux ARM64. Once the image is built, I can run it locally just to make sure all is good. And yes, this is what I'm expecting to see by checking that URL. Let's now stop the container and rebuild the image for AMD 64 architecture and push it to the private registry, because that's the architecture I'm planning to use for my Kubernetes cluster. Task allows you to run 2 commands in succession. You put the first command and then you put the second command. And like that, step 1 is done. Let's now deploy our Kubernetes cluster. I'll go through some snippets from the Terraform and PyInfra code that I'm using to deploy the single node Kubernetes cluster. You can find the full code of this repo in the video description. Let's start with this HCloud server resource. This resource will instruct Hetzner to create a new server instance with certain characteristics like type and location. The only interesting part here is the 2 provisioner blocks. The first one is a trick to wait for the SSH server to become ready. And the second one will actually trigger PyInfra with the IP address of the newly created server. Now, let's have a look at the PyInfra provisioning script. The first block is responsible for installing the K3s Kubernetes server. In general, shell scripts are not idempotent. That means it may not be safe to run them multiple times. So before running the install script, I do check that the K3s systemd service is not already installed. The next block adds a specific K3s config file that enables it to use our private registry. And lastly, I pulled the kubeconfig file from the server locally. I'm applying my Terraform code. And now it's waiting for the newly created server to have SSH ready. Once it's ready, I execute the real provisioner, the PyInfra script. Now all is done. I can check that our Kubernetes cluster is running by using kubectl command. I have already set my kubeconfig environment variable in advance to point to the newly downloaded file. And there we go, it's ready. And now we have a single node functional Kubernetes cluster ready for use. Let's now deal with the DNS record. I'm going to add a catch-all DNS record in Cloudflare. This will save me the pain of adding and deleting DNS records each time I create a new preview environment or delete one. I just pointed to our Kubernetes cluster server IP address, and based on the domain the request is sent to, Kubernetes will know which preview environment has to handle that request. The record has already been added because I have executed Terraform apply, so I'm just checking that everything works as expected by running dig on different subdomains and making sure that they all point to our Kubernetes IP address. test here. I can try ABC, same IP address, 123, same result, all looking good. Our catch-all domain is now operational. Let's switch our focus now to setting the necessary secrets in GitHub Action. This can be done using Terraform, specifically using GitHub Actions secret resource. I'm adding the kubeconfig file I pulled from the server, and the registry URL, username, and password. It's not necessary to put the registry URL, but I prefer to keep all the details of the registry together in case I need to change them in the future. I can do that in one place. Let's check these got created properly by going to the repo settings, actions under secrets and variables, and all looks good. Let's take a look at the Kubernetes resources that I will be generating for our preview environments. Even if you're not familiar with JSONet, it's very straightforward to understand. We are looking at the function that generates the deployment here. This function takes some parameters, then uses some of these parameters to generate a unique name for the deployment resource of our preview environment. That unique name will be associated with a specific container image. I'm just doing the same here for the service resource. The third resource I need to generate for our preview environment to work properly is an ingress. The noteworthy line in this file is how I generate the matching domain. I basically use our environment name as a subdomain added to the base domain. Then I do match based on that. Finally, I have to put all these functions together by importing them in my main JSON file. I then request some inputs from the user. I have decided here to generate the common variables in the main file instead of doing that repeatedly in each separate function. I then call these functions with only the needed variables. And finally, I generate the actual YAML Kubernetes manifests. JSONet mainly outputs JSON files, and I could have used that because Kubernetes accepts JSON. But I prefer YAML output to be able to easily debug or troubleshoot misgenerated resources, as I'm more familiar with YAML manifests. Okay, let's test this end-to-end. I'm here checking that I don't have a dev.preview environment deployed to our cluster. I should get a 404 not found when using curl. Yep, there we go. When I run k8s apply, it has a dependency on the compile task, so that will run first to generate the YAML manifests. I pass the end value here as dev. Let's check with kubectl and see what it says. We have a deployment successfully deployed. We have a service as well. And we have two ingress resources. This is expected. I have only talked about one of them. The other one is just a HTTP to HTTPS redirect. Let's now run the same curl command. I got redirected properly to the HTTPS version, so I'm going to add that. And there we go. We got our expected hello world. All working good. I'm going to share this quick tip with you. Even if I have a nice functional CI/CD pipeline, I always like to have the option to build, push, and deploy from my local machine. This has saved me so many times because the CI/CD was down or it got blocked for some other reason. Also, sometimes when firefighting a production issue, it can be extremely useful to be able to bypass the CI/CD, which can introduce some extra latency. Ask me how I know. But remember, this should be an exceptional measure, not the norm. You don't want to undermine your team's processes. That concludes the Kubernetes resource creation step. I'm now very close to the finish line. All that remains is to put together some GitHub action workflows that will trigger when I create a new PR, update the PR, and close that PR. This first workflow will create the preview environment. It will trigger when a new PR is opened, reopened, or a new commit is pushed. In GitHub's terminology, synchronized. I'm able to restrict this workflow to only trigger when I name my branches in a specific way, but I'm going to leave it to match all branches just for this tutorial. I can also ignore specific files and not trigger if they get modified. In this case, I don't want to trigger if I modify a markdown file. Once I have defined the triggers, I have to generate some strings in order to use them in later steps. The preview env name is going to be in the form of PR number-PR author. This string is going to be used in the resources names and as the subdomain used to access the preview environment. The next string is the full image name, which is composed of the registry URL, image name, and the short SHA of the current commit as a tag. There are many strategies to tag my generated images, and I personally prefer using the commit short SHA because I can quickly figure out what changes are currently deployed in the cluster just by examining the image tag. In this step, I build and push the container using the full image variable I defined previously. Once the image is built and pushed, I trigger the Kubernetes resources build and apply task like I did manually, and I pass my custom variables. The last step in our create preview environment workflow is to write a fancy comment in the PR to tell the developer that a preview environment was created or updated successfully. I'm using a GitHub action that offers JavaScript APIs to interact with GitHub. Again, this is a simplified snippet, so check the video description for the full version. I also should delete the preview environment once the PR is closed. There is a task for that. In this case, I only need to pass the app name and the env variable. The true at the end is to ignore any errors that could be thrown by kubectl in case resources are not found in the cluster, for example, because they got deleted manually. So this is the demo we saw in the intro. It shows the full flow end-to-end from creating the PR. So I made my changes and I'm committing these changes right now. Then I'm going to push them to GitHub. There you go. And in GitHub, I'm going to create the PR again. PR created. It triggered the workflow for me. I can see all the steps that I was explaining earlier. There you go, all successful. I'm gonna go back to my open PR. And there you go, I can see my preview environment is working successfully. I'm gonna make a small change as well to see that my workflow will also trigger when updating the PR in this case. There you go, doing the commit and push. It's done. Now it's gonna trigger the workflow. There you go. A few moments later, it says preview environment updated, and I can also see my changes. So now the last step is to actually close the PR. So I have merged my PR and it says preview environment cleaned up. So if I go and check the link I had earlier, it says 404 not found. So all has been cleaned for me. And like that, I have managed to build a CI/CD pipeline to deploy preview environments for every open PR in my repo. This was done by gradually decomposing this project into smaller, easily testable chunks and then putting them together to get this final result. So how can we improve this further, or what did we not cover here? We can tell our app that it's running in a preview environment by passing some specific environments variables at the time of build of the container. This can help the app slightly change its behavior compared to production. We can ignore and not build specific commits if the commit message contains a dedicated word, for example. We can also deploy dependencies required by the app, like databases with mock data, for example. But this is going to be highly specific to each app. Also, right now, we have all our preview environments running inside the same namespace in Kubernetes. We can have them running each in their own namespace. Did I miss something else? Please leave a comment below if you think so. I hope this was useful and fun to watch. The full code of this tutorial can be found using this link. I also offer consulting services, so you can book a free 30 minutes with me using this link. Both links are available in the video description down below. And if you'd like to see more videos like this, smash that like and subscribe buttons. See you in the next video.